Okay, hi folks, we're back during Hurricane Sandy with practice problem number 10 in Module 5. It reads, in a decomposition of 1.2 moles of dinitrogen pentaoxide, how many moles of oxygen will be formed? So first two things to consider. We have a decomposition reaction, and it tells us it's a dinitrogen pentaoxide. So the first thing we really need to do is figure out how to write the chemical formula for dinitrogen pentoxide. So since it's using those prefixes, we know it's a covalent compound, both nonmetals. Dinitrogen, so we have nitrogen, and di is the prefix meaning 2, and pentoxide, penta means 5, just like the pentagon. So we would write the chemical formula for dinitrogen pentoxide like this. We know it's a decomposition reaction, which means it's going to break down the compound dinitrogen pentoxide into its elements. So its elements are nitrogen and oxygen. We have to remember that oxygen is a homonuclear diatomic, so it has to be O2. So now we have to get a balanced chemical equation, making sure every atom that's here to start with is still there at the end. So we have 2 nitrogen atoms here. But we have an odd number of oxygens, so we're going to have to double this and do this. Then we have 10 oxygens on this side, so we want to have 10 oxygens on this side. 10 oxygens here, 10 here. 4 nitrogens here, 4 here. Now we have a balanced chemical equation for the decomposition of dinitrogen pentoxide. So then it tells us we have 1.2 moles of dinitrogen pentoxide, and we want to know how many moles of oxygen will be formed. Well, here is where real chemistry begins for you guys, using a balanced chemical equation to figure out something about a real amount of chemical. 1.2 moles being an uneven thing. We know that if we decompose 2 moles of dinitrogen pentoxide, we're going to make 4 moles of nitrogen. Oh dear, nitrogen's a homonuclear diatomic too. I'm out there. All wrong. Okay, so we're going to have this for the balanced equation. So now we're all good. So anyhow, we're going to have 2 moles of dinitrogen pentoxide decomposed into 2 moles of nitrogen gas and 5 moles of oxygen gas. But we don't know what 1.2 moles of dinitrogen pentoxide would decompose into. But it's very easy to convert using your balanced equation. It wants to know how many moles of oxygen would be formed. Well, I want to know moles of oxygen. So I could say 5 moles of oxygen is what I want to end up with. What I want to cancel out is moles of dinitrogen pentoxide. Well, I know that for every 5 moles of oxygen produced, I'm going to decompose 2 moles of dinitrogen pentoxide. This is just another way to use the stoichiometric coefficients in your balanced equation as a conversion factor to change one thing to another. You just cancel out moles of dinitrogen pentoxide. So I type into my calculator 1.2 times 5 divided by 2. And I would get 3.0 moles of oxygen would be produced by decomposing 1.2 moles of dinitrogen pentoxide. Keep significant figures. Now these stoichiometric coefficients, of course, are perfect numbers. They aren't just one significant figure, they're perfect. So you don't have to consider them. We have 2 significant figures here, so I'm going to keep 2 in my answer. I have a unit. I tell what chemical I end up with. So that's a complete answer. So anytime you have a balanced chemical equation, you can compare moles to moles and just put them in whatever order causes you to cancel out what you want to get rid of and end up with the units that you want to have in your answer. Make sure you do extra practice problems so you get a little more experience with that. And now I have a few extra problems just to make sure that you're feeling ready. These are not in the book, just extra problems. Oh, and I didn't start my timer, so hopefully I'll not run too far over. Start it now. So let's look at the combustion of C6H6. Now, this is hexane. A combustion reaction, as we remember, always has one other reactant besides the thing that's burning. Hexane is usually a liquid. What's the other reactant in a combustion reaction? It's always oxygen from the air, which is a homonuclear diatomic, and you always produce in a complete combustion reaction the same two products: carbon dioxide gas and water vapor, which is also a gas, which I can't fit in, CO2 and H2O. Then we have to rewrite that because that is terrible. Y'all can't see that. Hexane plus oxygen in the air gives us carbon dioxide gas, because of course combustion is always hot, plus water, which is a gas. Hopefully you can read that. Then we balance our equation. I'm going to start with the non-hydrogen and oxygen, the least common things, carbon in this case. So 6 carbons here, perhaps I can get 6 carbons here. But I'm always going to have an even number of oxygens here, not here at all. So I need to think about my hydrogen. 6 hydrogen. I want 6 hydrogen. That'll still give me an odd number of oxygen on that side, so I'll probably increase that. So then let's reconsider. I have 12 hydrogens over here, so I'm going to need 12 hydrogens over here. That's a 2. So that means that I'm going to end up with 2 times 6, 12 carbons there, so I'm going to need 12 carbons here. Okay, so now I think we have our carbons and our hydrogens balanced. We have 12 carbons on this side, 12 carbons on this side. We have 12 hydrogens on this side, and we have 12 hydrogens on this side. Now let's consider oxygen. We have 12 times 2 oxygen, that's 24, plus 6 times 1 oxygen. 24 plus 6 is 30 oxygens. On this side, how can we get 30? Well, 15 times 2 is 30. So we end up with 30 oxygens on this side. So now we have a balanced chemical equation. Very important. You can't do any stoichiometry until you write and balance the chemical equation for the reaction you're looking at. So, combustion of hexane here, we have the balanced chemical equation for that. Remember, always use oxygen from the air and combustion. Always produce carbon dioxide and water. And remember that you had to have enough oxygen to have a complete combustion reaction. If not, you form poisonous byproducts such as carbon monoxide and soot. When there's not enough oxygen, that can be very dangerous. You definitely need to make sure when you have a fire inside or anything like that, that you have plenty of ventilation, plenty of oxygen, so you're only producing these less toxic gases. Let's see, I might need to make another video. Better safe than sorry. I'm going to stop the video now and start one more video, and then we'll be all done with Module 5.